record. All right, there we go. I think we're live. I think so. Okay, so today we're talking about factoring polynomials. And one of the things we always want to do is we want to always common factor if you can. What does that mean? Well, always common factor. Well, what do they have in common? If you can do that, then you can make the problem easier, okay? So on example 1, it looks 2x cubed, 8x squared, 42x. So the first thing I'll do is just get rid of some numbers. So how do I get rid of them? If I can common factor, I will. So what I see is they all have a multiple of 2, right? So I can factor out a multiple of 2. So I'm going to do that first. So I'm going to take out a 2 out of all 3 of these, because 2 will divide into there, 2 divides into there, 2 divides into there, right? Thumbs up. And they all have an x in common, right? So if I take out an x, then that's common factoring. So once I take out their common multiple, and they all have at least an x in common, then I can see what's left over. So let's take out as much as I can. And then I'd have an x squared minus a 4x minus a 21, right? So let's see. I know to go backwards that if I multiply this times this, that's a 2x cubed, that's a minus 4x squared, and that's 42x. Okay, everybody thumbs up on common factoring, right? Now, can it be done again? Can it be done again? Again? Sure, I can factor again because that's a trinomial. And I know 7 times 3 makes 21, but negative 7 and a positive 3 would make the 4, right? Negative 4. So I can factor this again. Don't forget the 2x. And then I have an x minus 7 and an x plus 3, and that is completely factored, right? Okay. I know that negative 7 times 3 makes a negative 21, and then if I do remember the double smiley kind of thing, I'd have a positive 3x and negative 7x, which makes the negative 21. Okay, thumbs up on that one? Okay, good. Number 2. Okay, factor completely. Well, they don't. There's nothing in common. Common factoring, no. No. They don't have anything in common. But what I can do is this. I can do common factor. I can factor this like a trinomial. And the way I'd make an x to the 4th is I'd go x squared times x squared. Does that make sense? X squared, x squared. And 81. Somebody shout it out. What times what makes 81? Shout it out. Go on, you guys. What times what makes 81? 9. Perfect. How about if I go a positive 9 and a negative 9? I want to go plus minus because I need a negative 81, right? Nice job. Everybody good? Now, we can actually factor this one here again. We can't factor that because of the plus, but I can factor this one again. So I'm just going to leave this one alone. The x squared plus 9. But I can do this exact same process that I did up above, but with x. I can go x and x makes an x squared. And I go plus 3 minus 3, okay? Now, the reason I cannot do the first one, I want you to see this, okay? Okay, so we're smart. These are brains, okay, right? Positive 3x, negative 3x makes 0, right? Positive 3x, negative 3x makes 0. There's no middle term. You guys agree? Try to do this one again. X plus 3x plus 3. 3 3 makes a 6. There's no 6 there, right? This one cannot be done again. Okay, so that's it. Okay, let's move on to the next one. Number 3. Okay, factor completely. Wow, oh my goodness gracious. Those are humongous numbers, but I've got a calculator, okay? So first of all, I know 10 goes into both of them for sure, right? You guys agree? So if I take out a 10, I'm sure 10. You guys agree with 10? So let's take out a 10 and see what I get. 10. And then I'd have a 81 x to the 4th minus a 16, okay? Ah, now that's starting to look like something I could do, okay? Okay, I'll ask it again. What times what makes 81? What times what makes 81? Come on, you guys. What times what makes 81? 9, right? What times what makes 16? 4 and 4. So let's do this. Let's go. And we're going to factor it like we did this one up here, okay? we're going to go 9x squared, 9x squared, okay? Because that'll make my 81x to the fourth. And then I'm going to go plus 4 minus 4, right? Because that'll make my negative 16. And just like up above, I can probably do that one again. I can factor that one more time. So I'm going to go 10, 9x squared plus 4. And then I'll factor this one again. I'll go 3x, 3x. I'll go 2 and 2. 3x, 3x, and 2 and 2. So I'll go 3x times 3x. 3x times 3x makes the 9x squared. And I'll go a plus 2 and a minus 2. And that is it, as far as we can go with that one, okay? Okay, how am I doing? Okay, turn the page. Now, we did this last year, but if it has 4 terms, okay, four terms, we do a thing called grouping, okay? So to do grouping, you pair them up, okay? So to pair them up, I'm going to put these first 2 together and these first 2 together, okay? So pair them up. See, 4 terms, pair them up, okay? So now what I'm going to try to do is I'm going to try and common factor. Well, let's see. So I'm going to ignore this for a second. I'm just going to look at these 2, okay? That's all. So I'm going to try and just only pair them out. So what do these 2 have in common? They've got an x squared, right? They both have at least an x squared in common. So I'm going to take out my x squared. Out of just these 2. I'm going to ignore this one, okay? I'm ignoring that one completely, okay? So if I take out the x squared, I'd have a 5x plus 2, okay? How am I doing? Now the second group really doesn't have anything in common except, what's the one thing you see they have in common, these 2? What's the one thing these 2 have in common? What do you see? Do you see the negative? They both have a negative. So I'm going to take out a negative 1, because that's what they have in common. And let's see if that helps. So if I take out a negative 1, I have a positive 5x, and I'd have a positive 2. Now here's what must happen for this to work. Whenever you do grouping, you need to get the same thing twice. If you don't, then you're done. But on these grouping problems, you always need to get here where you get the same thing twice. So then you factor again. So if I factor again, what do these 2 have in common? Well, they've got the parentheses. They have the parentheses 5x plus 2 in common, okay? And even though there's 2 of them, you only count it once. So I sometimes like to cross it out so you don't get confused. But they have the 5x plus 2 in common. I take that out of both. And then what's left over? Well, if I take that out and put it there, well, then what's left over is the x squared minus 1. Okay, now these are hard. We're in Algebra 2. This is not obviously geometry anymore because we can do this one more time. Okay, oh, what do you mean? Sure, check it out. Just like we did this, remember? Like we did this one, x squared minus 9, right? We can do this x squared minus 1 again into an x plus 1, x minus 1, and then I'm going to make sure I bring this down, okay? So if you guys ever have to take Algebra 2 in college, this is always what hurts kids, are these kinds of problems, okay? Hopefully you guys can do these, because these are hard, right? All right, or call Mr. Davies up, huh? Say, help. All right, number 5. So there's 4 terms, right? 4 terms. There's 4 terms. So I'm going to group them. I'm going to put these 2 together and these 2 together, right? All right. So the first 2, what do they have in common? First 2, what do they have in common? What do they have in common? Go ahead, Abby. X cubed, right? They've got at least an x cubed in common. Now, before you take out the x cubed, put a 1 right here because it's invisible. But there's an invisible 1 right there, right? It's going to help me. So if I take out the x cubed, out of these 2, right, then I'd have an x squared plus 1, right? And then the second term, what do they have in common? What do they have in common? Just the negative, right? Just the negative. So if you take out a negative, and I call it a -1 because it's invisible. If I take out the negative, I'd have an x squared plus 1. And again, what we're looking for is we want something to be the same. We do. Okay, when we do grouping, this is our goal is to get to here, okay? So then finally, we're going to say, what do they have in common? They've got the x squared plus 1 in common, because I take it out, and what's left over is an x cubed minus 1. How's that? Okay? All right. So, homework is down here out of your journal, and I'm going to do your homework with you today. How's that? See, this is so nice about being in class. So I'm going to do it with you because